Over 4,000 missiles were fired at it. Not one hit. The SR-71 Blackbird flew 53,490 feet, more than 10 miles, above the Earth's surface, at speeds that would take it from New York to London in under 2 hours. And every single time an enemy tried to shoot it down, the crew got a warning light, pushed the throttle forward, and simply outran the missile. This isn't folklore. This is documented, confirmed, and frankly one of the most remarkable engineering stories of the Cold War. So today we're answering the question, why was the SR-71 Blackbird never shot down, not once in 24 years of operational service? The answer has 3 parts: speed, altitude, and a design philosophy so aggressive it bordered on insane. Before we get into why it couldn't be shot down, you need to understand what this aircraft actually was, because nothing like it has existed before or since. The SR-71 was a strategic reconnaissance aircraft. Its job wasn't to drop bombs or shoot down enemies. Its job was to fly over denied territory, the Soviet Union, North Korea, the Middle East, take photographs, gather signals intelligence, and get out without being touched. It was designed in the late 1950s by Lockheed's legendary Skunk Works division, led by engineer Kelly Johnson. The project was so classified that even most of Lockheed's own employees didn't know it existed. The plane first flew in 1964. It entered operational service in 1966, and it kept flying, actively, operationally, until 1998. Here are the raw numbers that matter. Top speed, Mach 3.3, roughly 2,200 miles per hour. At full throttle, it covered a mile every 1.6 seconds. Operational altitude, 85,000 feet, nearly 3 times the cruising altitude of a commercial airliner. Range, 3,200 miles unrefueled, and it could be refueled mid-air. To put the speed in perspective, the fastest air-to-air missile of the Soviet era, the AA-6 Akrid, had a top speed of around Mach 4.5. That sounds like it should be fast enough. But as we'll see, speed alone doesn't tell the whole story. This is the part most people don't fully appreciate. Shooting down a high-speed aircraft isn't just about having a faster missile. It's about intercept geometry. A missile needs to be launched far enough in advance, at the right angle, with enough closure speed to actually reach the target. The SR-71's speed broke that geometry entirely. Here's how a typical shoot-down attempt played out. A Soviet radar installation detects the Blackbird approaching. They calculate its course, compute a firing solution, and launch. This entire process, detection, tracking, targeting, launch, takes time. During that time, the SR-71 has already moved. The missile is now chasing a plane that is no longer where the trajectory assumed it would be. The crew received a warning the moment a radar locked onto them. Standard procedure: light the afterburners and accelerate. The plane could go from cruise speed to Mach 3.3 plus with surprising quickness, and at that point, even a missile already in the air couldn't close the gap in time. Pilots described it matter-of-factly. The missile warning light comes on. You push up the throttles, and eventually the missile falls away. That's it. 85,000 feet is not just high. It is operationally unreachable for almost every weapon system deployed against it. Most surface-to-air missiles of the Cold War era were optimized for targets between 40,000 and 70,000 feet. Above 70,000 feet, the atmosphere becomes so thin that aerodynamic control surfaces barely function. Missiles that rely on fins and lift to steer themselves lose authority rapidly. They can reach the altitude, briefly, but they can't maneuver effectively up there. The SR-71 exploited this. It flew in a band of sky where the physics worked against the missiles and for the aircraft. Fighter jets had even less chance. No interceptor in the Soviet inventory could reach 85,000 feet at sustained speed. The MiG-25 Foxbat, specifically designed as a high-altitude interceptor, could theoretically reach those altitudes in a zoom climb, but it would be flying near its operational limit, with almost no energy left to maneuver or fire effectively. There's a documented case from 1987 where a MiG-25 attempted an intercept over the Baltic. It climbed to its ceiling, fired a missile, and failed. The Blackbird crew didn't even need to take evasive action. The missile simply couldn't complete the intercept. Speed and altitude were the primary defenses. But the SR-71 had backup survival layers baked into its design. The aircraft had an extremely small radar cross-section for its era. It wasn't stealth in the modern sense. The F-117 wouldn't exist for another 2 decades. But Lockheed shaped the fuselage and applied iron ball paint, a radar-absorbing coating, to reduce its reflectivity. By the time radar operators got a clean, reliable lock, the aircraft was often already past the threat zone. The titanium structure also meant the aircraft could sustain the aerothermal heating of Mach 3+ flight. At those speeds, friction with the atmosphere heats the airframe to over 600 degrees Fahrenheit. Aluminum would fail. Titanium didn't. The plane was literally built for a regime where other aircraft would come apart. And then there's the psychological factor. The crews knew the rules of engagement. If a missile warning appeared, the answer was never to evade, it was to accelerate. That counterintuitive confidence, we don't dodge, we outrun, was baked into training from day one. The Blackbird flew over North Vietnam repeatedly during the Vietnam War. North Vietnamese air defenses, Soviet-supplied SAMs, some of the most sophisticated of the era, fired on it every time. They never came close. It flew over the Middle East during the 1973 Yom Kippur War, providing the United States with real-time battlefield intelligence. It overflew Libya. It overflew North Korea regularly. Every adversary knew it was coming. Many tried to shoot it down. None succeeded. Perhaps the most telling detail: the aircraft never carried weapons. Not a gun, not a missile, not a defensive system of any kind beyond its radar warning receiver. The designers were so confident in its speed and altitude that they concluded any additional weight would be a net negative. The best defense was the performance envelope. In total, the SR-71 flew over 1,700 hours during its operational life. It was retired not because it became vulnerable, but because satellites and drones became cheaper alternatives for the same mission. The threat never caught up. The program simply ended. The SR-71 Blackbird represents something increasingly rare in engineering, a machine so far ahead of its adversaries that the adversaries never closed the gap. It was conceived in an era before digital avionics, before fly-by-wire, before computer-aided design. Kelly Johnson's team built it with slide rules and extraordinary instinct. It flew faster than anything that wanted to kill it, higher than anything that could reach it, and it did that for over 2 decades without a single combat loss. The next time someone tells you that brute force performance is obsolete, that it's all about stealth and electronics now, remember, the fastest plane ever built by the United States was also the one no enemy could touch. Not once. Not ever.